Welcome to all my dear students. Today I am going to discuss with you protectives and adsorbent. So protective, what is the definition for protectives and adsorbents? Are the chemically inert substances which are used in the treatment of diarrhea. For example, here under this protective and adsorbent examples are kaoline and bentonite. These are have much more pharmaceutical use, also to be used for the treatment of diarrhea. So what is the definition for diarrhea? It is defined as the frequent passage of watery stools or liquid feces as a result of increased motility in the colon. The stool may contain blood, pus, mucus, or excess quantity of fats. So it may be divided into or classified into chronic or mild diarrhea. So mild diarrhea is due to bacterial infections with their toxins, side effects of some drugs, hypersensitivity, accidental or intentional poisoning. So might be there are the different cause for the occurring of mild diarrhea. That means bacterial infection with their toxins, side effects of some drugs, hypersensitivity, accidental or intentional poisoning. So these are the main occurring of the mild diarrhea, while chronic diarrhea is due to the GIT, that means gastrointestinal tract disturbances, absorption and inflammation. So excessive discharge of intestinal content leads to the loss of electrolyte, so which give rise to dehydration or electrolytic imbalance. So suppose the continuous discharge or excessive discharge of intestinal content leads to what will happen? So excess loss of electrolyte, thereby it rise to dehydration or electrolytic imbalance. So in order to compensate this, we have to take lot of ions concentration, that means ion electrolyte, that means ORS. So inorganic compounds such as bismuth subcarbonate, kaoline, bentonite, etc. are insoluble salts which are used as protective and adsorbent. So according to your first year for first semester syllabus, we have to much more give attention on kaoline and bentonite. These two drugs comes under the use of anti-diarrheal effect. Okay, so let's see about what is the kaoline, monograph of kaoline. So kaoline is nothing but synonym chena clay, a molecular weight Al2O3, 2 silicon dioxide, 2 SiO2 and 2 molecules of water. And what is the molecular weight? 258.16 gram per mole, 258.16 gram per mole. There are two types of kaoline, heavy kaoline and light kaoline. So heavy kaoline is derived from the decomposition of the feldspar of granite rocks occurs in various parts of the world. So kaolin consists chiefly of an aluminum silicate of the composition. So kaolin is nothing but aluminum silicates of the compositions. Here the formula already I gave you, Al2O3 2Si, that means aluminum silicate of the composition with traces of compounds of magnesium, calcium and iron. So Fuller's earth is a porous silicate similar in composition to, that is also one of the type of protective and adsorbent. It is similar in composition to the kaolin. So in that light kaolin is a native hydrated, and this is also hydrated aluminum silicate and it is finally divided form of kaoline, specially intended for internal use. So that means diarrheal use. Then preparation, how can we prepare the kaoline? It is widely distributed in nature, contaminated with ferric oxide. That means it is widely distributed in nature wise, so it might be contaminated with or mixed with some ferric oxide. So it is prepared when the rock is mined, evacuated, and the impurities are washed with water and then powdered. So for pharmaceutical use, it is purified by treatment with hydrochloric acid and sulfuric acid, or otherwise both, and washed with water. Then it is for pharmaceutical use, it is finally acidified with the hydrochloric acid or sulfuric acid, or sometimes both, and finally it is washed with water. Now both heavy kaolin and light kaolin for pharmaceutical purpose, it is free from gritty particles by elytration. Elytration is a technique, that means it's a process to from that we can separate are based on their size or shape and density, using a stream of gas or flowing liquid in a direction usually opposite to the direction of sedimentation. Elytration is a process so that we can separate the particle size accordingly. Okay, so usually both heavy kaolin and light kaolin to be used for pharmaceutical substance, it is mainly free from gritty particles. For that, in order to get the free fine powder, so we have to use the elytration process to separate the particle size, density and shape of the substance. Okay, next property, let's see. Color, soft white yellowish powder, and taste, it has a clay like earthy taste, and solubility, it is soluble in water, and characteristic, it is free from gritty particles. Next we'll see about identification. That means fuse 2 grams of the substance with 4 grams of anhydrous sodium bicarbonate. The 2 grams of the substance with sodium carbonate to be fused with or warm the residue, then filter, then acidified with hydrochloric acid and evaporated to dryness. So warm residue with hydrochloric acid, residue of silica obtained. Okay, then we'll go for test for aluminium. This acid solution, first what we are going to do, that 2 gram of the substance by adding with sodium carbonate and warm the residue, then thereafter acidified with hydrochloric acid solution. So this acid solution contains silica. So now we have to carry it out for the test for aluminium. So the metal crucible 0.5 gram and add 1 gram of nitric acid and 3 gram of sodium carbonate. Melt and allow cool, and add 20 ml boiling water. Filter, then 1 ml of sodium hydroxide to filtrate and get the filtrate. So 3 ml of ammonium chloride solution, a gelatinous white precipitate obtained. So after acid solution of silica is obtained, then this test to be carried out for aluminium. For that we are going to add nitric acid and sodium carbonate. Let the solution to melt and cool it, and then after adding boiling water, then neutralize with sodium hydroxide and titrated and add ammonium chloride solution. Then we have gelatinous white precipitate. So now next we'll see about what are all the tests for purity to be carried out for the kaolin. So as usual, test for arsenic, lead, chloride, loss on drying and loss on ignition, and soluble matter. Light kaolin is always required to comply with limit test for coarse particles. So particles larger than, so I already told you that these light kaolin, both light and heavy kaolin, to be used for pharmaceutical substance should be free from fine particles. So the particle larger than 10 microns in diameter and particles larger than 3 micron in diameter should meet the criteria. Next, what is the uses? So it is topically used as protective in lotion, and other than that of diarrheal action, it is also to be used as ointment for the preparation of protective in lotion and liniment, astringent and adsorbent in diarrhea, as poultice, dusting powder, classifying and clarifying and decolorizing medium. That means and decolorize if for the colored substance. So if we are adding that kaolin, then it is to be used to decolorize the substance, and as filtering medium and also used as a diluent in tablet preparations. Thank you.